Um, Yesterday we talked about the perimeter and circumference. Today what we're gonna do is we're gonna talk about area and an area of a two-dimensional figure. Two-dimensional figure. So the area is a measurement of the enclosed space inside the two-dimensional shape. So we're going to focus on two-dimensional shape. Two-dimensional shape is a flat shape. Flat. Okay? Now, there are formula for depending on which figure it is.
Students are welcome to attend the presentation from the Manitoba Tourism and Education College today from 11 to 12 in the student lounge. All the training is less than 2 months long and there's a good chance to get government funded to be trained as a bartender, line cook, front desk clerk in a hotel, and many more options in the hospitality industry. So what are you waiting for? Come on down.
Yeah, she did. So in example number 1, it says determine the area of a triangle. Determine the area of a triangle. What does that? How can we figure out the area of these? Do you know what the centimeter is? Do you know? Okay. 3 centimeter is the height, and then the 4.5 is the base, right? So, depending on what shape you have, there's different formula for that. Okay, so if we take a look at this page, so if we're talking about the area of a square, the area is length times width. This one's supposed to be times. Length times width. And then if we're talking about a rectangle, it's also length times width. What's the difference between these two? They're both length times width.
One's a square, one's a rectangle.
Yeah. And then this is length and then this is width. The areas will be different, yes.
From a square, they're all the same length each.
That's right. Yeah.
Each side.
Correct. Very good. So the square, the only thing that's different between square and a rectangle, it's length times width as well, right? It's just that the length is the same thing as the width. They're equal to each other, right? So if this is 4, and then this is also 4. Okay, so I just want to point that out to you. Here's a triangle. The triangle is B times H divided by 2. Okay, well, what do you think the B represents? The bottom or the base? Yeah. The base. And then what do you think the H represents? Height. Why do you think it's divided by 2?
2 different sections.
Why is it divided by 2?
2 areas. Right? 2 areas.
Because two sides are the same.
Okay. So the base doesn't have to be the same as the height. So what are you thinking about? You're kind of gesturing with your hand. What are you thinking about? Yeah. Why is that? Half of the triangle.
Showing 90 degrees on one side.
Instead of pizza slice, and you
This is 90 right here.
Yeah. Like using one side.
Mm-hmm. Half, okay. Okay, interesting.
Because we're looking for two sides.
Two areas, yeah, yeah. But they're not the two. That's not two equal areas.
Yeah, no.
Okay, good.
You're gonna divide the height and the base by 2.
Mm-hmm. We're gonna divide the base and height by 2. Okay.
Because there's a line already, there's a triangle, it's a 3-sided triangle, which is all equal. But it looks like a pizza, but if you don't add that one part to it. you
This
just-
part? Okay.
Yeah, then you just put a line where that little square is,
Mm-hmm.
2, and it would divide it by each
Okay.
side. Like each angle still come out to the same number.
Okay.
And maybe some A's stand for altitudes?
Now, we're just talking about why is it divided by 2? We understand the base and the height, but we can't divide. What does it mean by dividing it by 2? Let's take a look. Let's take a look. I'm gonna redraw this on a separate sheet of paper. I'm gonna draw this on a separate sheet of paper and then tell me, and then hopefully we'll see why it's divided by 2. Okay? Because it's one thing to know Okay, so this is gonna be the base, and then the height would be here. Yeah. And what does this symbol mean? I think some people might know that already. 90 degrees, isn't it? So that base, we'll talk more about that when we get into trigonometry. This base and then the height are called perpendicular to each other. Now, why does it have to be straight? Okay. Now think about your own height. How do you measure your own height? How can a person measure our height?
By feet.
By feet. Okay, how do you stand when you, okay, if I go measure my height, I'm gonna go measure my height, please.
And
No, that's not my height, right?
if you want to measure yourself, stand on the wall.
Right? That's not my height. This is not my height. How do you measure my height?
Stand
I
straight.
gotta stand straight. I gotta stand straight, perpendicular to the ground, right? So when you think of the height has to be like that,
Straight.
perfectly vertical from the base, right? Okay, so that talks about that height. Okay, we're still kind of figuring out why is it base times height, and then all of a sudden, you gotta divide by 2. Well, this is kind of weird. Like, where did the 2 come from? Okay. Two sections, okay? Here's what we're gonna do. I'm gonna try to enclose this. Okay, I'm gonna start with that one. So the base is still here. How long is this?
90.
No, how long?
3.
This is the same thing
Same.
as the
That height.
as the height, yes? Yeah, everyone's following? Yeah, okay, yeah. Because if this is height, and this is height, that's height. Okay, good. Okay, let's focus on this rectangle. What do we do? If we want to measure the area, is length times height. Okay, length times height. Well, these two triangles are, what do you notice about these two triangles? The same. Yeah. Do you see that they're the same? Yeah? It's the same, but what happened? It's just upside down, yes? Okay, now what about this one? What about these two triangles? What do you see? They're the same, but what happened? Flipped upside down too. So here, if we take a look at that part, the whole thing, this one should be the base, and then this one times the height. Well, if I go base times height, that's the area of this rectangle, right? We don't want the area of the whole rectangle. We don't want to, we just want to make sure we get rid of the other half. We're only taking half of that, half of this rectangle. So that's why we had to divide it by 2. So that tells us we're only taking half of the rectangle that I made on the outside. Is that clear? Yeah. So that divided by 2 is because we don't want to take the whole rectangle, get rid of that half, and then get rid of this other half in here.
So if there was numbers, then how would you?
Yeah, we'll get to the equation. We'll get to the example. Now circle. Circle is a funny one, right? The only thing that we need is r. Because pi is the ratio 3.14. What do you think the r means? Radius. Yeah, radius. And how did we define radius yesterday?
Radius a half
Half of
and center.
the diameter.
From center.
Yeah, from center to the edge of a circle. Okay? So, here's the formula. We pick, okay, which figure do I have? Once we figure out the figure, the shape, then we get to do the area. So let's take a look at this one. Starting off with the area of a triangle. So what's the formula for this? Area of a triangle. So A equals to base times height divided by 2. Base times height divided by 2. So that's our recipe. We're going to put all of our values inside. So A equals, okay, I gotta write down the B value. What's a B value? 4.5, yes, 4.5. Times height is 3. Divided by 2. Okay. Let's figure that out. So 4.5 times 3 divided by 2. 6.75. Yeah. So 4.5 times 3 divided by 2. 6.75. 6.75. 6.75 what? Yeah, centimeters square, or square centimeters.
Put that little E through there.
Yeah, you need to put the 2 there. Okay, I'll explain that tomorrow, okay? I'll explain that more in detail tomorrow. Yeah. Now let's take a look at example 2. Determine the area of a circle. Okay, look at this one here. I'm supposed to find the area, and what's the shape? Circle. So we gotta take a look at what is the appropriate formula for that. So let's go here on our formula sheet. Okay, so area, where's that one? Area formula, circle. It's A times pi times r squared. So let's write that down. A is equals to pi times r squared. So what are we going to do? A times pi, A equals pi times r. 2, we're going to replace the r by 2, and then square that. So we learned about squaring before, right? Exponents. So let's try that. So what's pi times 2 squared? Pi, let's use our pi key. Times 2 squared. Okay? Now, each one of us different way to do the squaring button. Are you okay with squaring?
I don't have a calculator.
Oh, no, the exponent 2.
Okay.
You're gonna need it.
That's okay, I'll use my phone.
Oh, okay.
Yeah, that's okay. Yeah. I'm just gonna use my phone.
Hey, that's double.
I know. Bruh. Oh, yes, thank you. I normally bring more calculators. More than one. Okay, so pi
Yeah.
did you get 12.566? Yeah, 57. Okay, yes, thank you for correcting me. At 12.57, yeah, if we round it off to 2 decimal places, what's a unit? Centimeters square. 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 You need a calculator? You need help with that? Okay. Yes, everybody got 12.57? Yeah?
Yeah.
Okay, good. Yeah. So Jane is just checking, see if you're in, if you need help, just wave at her and she'll help you with your calculator. I think for the most part, should be good. Example 3. determine the area of the rectangle. Okay, so go ahead and take a look. What is the strategy that we're going to use to find the area of a rectangle? A, yeah. L times W, and then the L means length, yeah, you got it, and the width. Okay, good. So what are we going to replace the L by? 15 times 8. Okay, so that's going to give you 120. 120 what? Feet. Okay, because this says feet. Feet squared. They're squared feet. So the area is a Is that good?
So that's like how much, 120, that's how much cube to put it inside that rectangle?
Yep. That's how many squares can fit in a rectangle. Yeah. Oh, okay, you're already kind of talking about what I'm gonna talk about tomorrow, but that's good. That's good. Now you get. We're gonna talk about it tomorrow, okay?
That's why you got us
Eventually, yeah. I don't know. I don't know what else I'm gonna ask you to measure. Okay, now this is crazy. Oh, is that okay? We're on like, page 6 now. We're so good?
It's on page 4. No, on page 3. Yeah, page 4.
Okay, I will lend you the notes, okay? Let's keep going. This is a weird one. Okay. Well, we're trying to find the area of this shape here. Well, what shape is that? An L shape. But we're kind of thinking like, I don't see an L shape. How can I calculate the area of that shape when it's not even in my list of formula? Any idea on how we could do that? Yep.
Would you use two different formulas, the rectangle and then square?
Oh, okay. Let's take a look.
Times width.
I don't know what you meant by rectangle and square. Do you want to come up here and explain? Or do you want to go up there and kind of explain it there?
No, because it looks like a rectangle on the way, right? On one side,
I don't know what you're looking at. Go up here and
like right here. Right here, you put a line here. It's a rectangle,
oh,
right? So
okay.
length times width, or no?
Oh, interesting. Well, that's very interesting. Yeah.
Then use this as the rectangle. Oh, I don't know.
Okay. Yeah. Yeah.
That's what I was thinking.
Yeah. Okay. Good. Good.
Unless you make a straight line up and make it into a
Okay. So, show everybody again what you were you're covering it a bit.
You divide over here. Yes. You put 3 times over here. It's like a rectangle. Have a square.
Okay. Okay.
That's how I see it.
Okay, yeah, good. Well, both of you see it differently or cutting this L shape differently, but that's perfect. Both of you are correct. Both of you are correct. Okay? So, how about let's try cutting it off this way. Okay? Let's see. we're gonna also try the other one. Okay, we're gonna try both, and we should get the same answer. It's the same area. We should get the same answer, right? So I'm gonna focus on this rectangle or whatever that shape is. Okay, so I'm gonna focus on this one. I'm gonna call it area 1, and I'm gonna look at this one as our area 2. Yes, I think that's what you were thinking about. And how do we find the area of this one? Cover that piece. This is length times width, right? Length times width. I got the length here, 7. Well, what's the width?
9. 20 minus 19.
Well, it's a
Just
square,
9.
usually a square is, their sides are all the same.
If it's a square, yeah, but this one here, we don't know if it's a square really.
But 28 minus 19, we have it.
Okay. So we know the length is 7. How big is the width? Soon, would you mind going up there and kind of pointing out where you're saying 9? Because that's okay.
This one. Here it is.
Okay, I'll bring it down for you. There you go.
28. Already here 19. How much? Down. 28 minus 19.
Nine,
Now, does everybody see that? Yeah. Very good. Very good. Thank you. Everybody saw that, right? Yeah? So she's saying that 28, this length, and then this length, right? 19 and a little bit will give us 28. So how much is that little bit right there? So if you go 28 minus 19, that's going to give us 9. So if this is 9 there, then that means this is 9 there.
If it's 7 on top, it's 7 on the bottom.
Yeah, if it's 7 on top, that's 7 on the bottom.
And then that's the same way, oh yeah, and then.
Okay? So now we want to figure out the area of these. So area is equal to length times width. Okay, length is 7 times width is 9. So 7 times 9 is 63. 63 what? Meters squared, square meters. Okay, so the area of this is 63 square meters. Now let's take a look at this part. This is a rectangle, yes? So the formula is length times width. What is the length here? I'm going to cover this part because I don't want us to get confused. What is the length?
28. I mean, the length, yeah, 28.
Okay, it's 28. So you're saying that this is the length. Okay. And then what's the width?
15 take away 7.
Now, this is, the whole thing is 15.
Take away 7.
But then this is from here to here is 7. So that makes this 8. Right? Because we can't say 15. That's not how long it is, really. It's only up to this part.
It's 7.5.
So it would be 7 plus something will give you 15. So 7 and 8 will give us 15. So 28 times 8. It's going to be 224 meters squared. That's area 2. So you got area 1 and area 2. Area 1 and area 2. Now, how much is that all together? So total area, yeah, you're gonna add them up. So A is equals to 63 plus 224. That's gonna give us 287 meters square, or square meters. Are we gonna get the same answer if we cut it differently?
Should be.
It should be, because it's the same shape, right? The same shape. So even though the other possibility is to cut it this way, you should get the same answer. Okay. I think this is the best place to stop at this time. We're gonna continue this tomorrow. So we have one more example tomorrow, and then we'll see. Oh, tomorrow's your Wednesday. Yeah, tomorrow's your last day, right? Because there's no school on Friday. No school on Friday.